Good morning. I am Devi Abhirami, Assistant Professor, Department of Mathematics, Dr. SNS Rajalakshmi College of Arts and Science. Today I am going to take a topic, test of hypothesis using large sample. Their problems and solutions are discussed here. My very first problem is the mean breaking strength of a cables supplied by a manufacturer is 1800 with the standard deviation of 100. A new technique in the manufacturing process, it is aimed that the breaking strength of the cable has increased. In order to test this, claim a sample of 50 cables tested. It is found that the mean breaking strength is 1850. Can we support the claim at 1% of level of significance? This is a large sample because the sample size is 1800 and the standard deviation is 100, so it comes under the large sample. Now we are going to test the hypothesis. For the level of significance is 1%, 1% is 0.01%. That is the population mean mu they have given is 1800 and their sample mean they have mentioned that is 1850 and the sample size is 50. Now I am going to solve this problem by using an hypothesis formula. We know the hypothesis formula which we have explained in the previous video itself. The hypothesis is of two types. One is null hypothesis and another one is alternate hypothesis. Null hypothesis means the sample and the population mean should be equal. If it not, then we can go with an alternate hypothesis. This can be calculated by using an z-test formula as x minus mu divided by sigma by root n. X is nothing but the sample mean and mu is nothing but the population mean and sigma is the standard deviation and n is the number of population. They have given all the values. I am going to substitute those values in my formula. From substituting this I am having the answer as 3.54, approximately 3.54. My critical value is for 1% level of significance. So 1% level at Z is 2.33, which is very greater when compared to my result. So if it is greater, then we can tell that we can reject our null hypothesis, that the sample mean and the population mean cannot be equal. Therefore, there is a sufficient evidence to support the manufacturer claim. The new manufacturing technique has significantly increased the breaking strength of the cables. And the second problem is an ambulance service claims that it takes on an average 8.9 minutes, that is x bar is equal to 8.9 minutes to reach the destination in an emergency calls. To check on his claim, the ambulance service has 50 emergency calls. Therefore, the sample size is 50 and the mean time they have given is 9.3. Standard deviation sigma or S can be calculated by using 1.6 minutes. What can they conclude? 5% level of significance. So similarly, I am going to test the hypothesis, null hypothesis and the alternate hypothesis, and checking whether the null hypothesis is accepted or rejected. For this case also, I am going to use the Z formula. Z formula is x bar minus mu divided by sigma by root n. So I know all those values. The null hypothesis is stated as the population mean and the sample mean are equal, whereas in the alternate hypothesis it is not equal. It is a two-tailed test, so I am going to use an Z formula as x bar minus mu by S by root n. So if I solve it, I will get the answer as 1.77. We know that the critical value of 5% is 1.96. In the previous problem, they have mentioned the level of significance is 1% and here the level of significance is 5%. The level of significance will differ problem to problem. We know that the Z value is 1.96 whereas our value is 1.77, which is very less when compared to the Z test table. So if it is less, we can fail to reject the H0, which means we can accept our null hypothesis. Our null hypothesis is nothing but the average response and the sample response will be equal. So we can conclude that the average response time is consistent with the claimed of 8.9 minutes. And the third problem is same as the previous problem. There are sample of 625 bulbs The company has an average life of 1000 to 10 hours with a standard deviation of 80 hours. Can we conclude that these bulbs are drawn from a large population having a mean life of 1200? So the standard deviation they have given is 80 hours. As we have said in the previous problem also, here also we are having a 5% level of significance. We are going to test the hypothesis. For testing the hypothesis, I am defining two hypotheses. One is null hypothesis and another one is alternate hypothesis. Null hypothesis means the population mean should be equal to 1200, otherwise it is not equal. So similarly I am going with my formula x bar minus mu by sigma by root n. So if I substitute it, I will get the answer as 3.125. So my critical value, already I have said it is 1.96. When compared to my z value, it is very great. So we can reject our null hypothesis. So we can conclude that the bulbs are not drawn from the population mean. That is, the population mean and the sample means are not equal. This is how we can test the hypothesis by using an z test formula. This is how we can test the hypothesis by assigning a null hypothesis and an alternate hypothesis. By using an Z formula, we can conclude whether the null hypothesis is accepted or rejected. If the null hypothesis is accepted, then the problem is completed. If it is not accepted, then we can go with an alternate hypothesis. Thank you.